Viewing from Worthing to Beachy Head Cliffs, the 5th of May 2019, a Sunday, 16:20 was the time. The distance, 44.2 kilometers, 27.4 miles. All previous reported observations have previously been carried out during the evening or night. It was decided to start observing the coast during the day. This is the first observation. My apologies for not having published a complete video on the first Bedford level observation. From the footage taken on the day, as stated in the preliminary YouTube published, no conclusion can be reached concerning the profile of the Old Bedford River due to the amount of distortion and refraction that was occurring on the day. More time is required to analyze and discuss the associated optical phenomena to acquire a thorough understanding of the observations before they can be accurately presented. Work and learning in progress. Thank you for your patience. Location, Beachy Head. Location, Worthing Sailing Club. Location, Worthing Sailing Club, Groin Breakwater. Weather information for Sunday the 5th of May 2019. Summary. In terms of weather conditions, as will be seen from the video footage, it would have been considered as a normal day. The humidity was low, which resulted in good visibility along the coast. The wind was blowing in a southerly direction, away from the land, towards the sea, which helped increase visibility along the coast. The sun was behind the camera observer, resulting in the sunlight reflecting off the white coastal cliffs, accentuating their appearance. The coast east of Worthing Yacht Club was observed with a Nikon P900. Here is the video recording.
We are at Worthing Yacht Club in Goring by Sea, and it is low tide, and we are going to have fun with the camera. And the time is, as always, this is the colours. Trying to actually get the time. That's better, right. (6:20) May the 5th. 6:20 May the 5th. What a nightmare. Right, we're in Worthing, Goring, 6:20 May the 5th. It's low tide. We shall get tide heights in a minute. is Rampion Wind Farm. It's good. No. There is Rampion Wind Farm. You can see the yellow bases, and you can see the struts on the substation because of course it's low tide. And we're going to scan out. Now we're going to have a look at Worthing Pier and then to Brighton. Okay. So Worthing Pier there. And Brighton is behind Worthing. There we can see the cranes of the hospital. I-360's behind there somewhere. There's the cranes of the hospital in Brighton. They show the 4 or 5 red lights at night. And we're going to start to scan towards Seaford. You can see the cliffs. There you see those. Definite refraction going on. See what we can see. Some more cliffs. Refraction going on. And there the land ends. Definitely got land end there. I don't know how far away that land is, but it's definitely there. I don't know how high that land is. Zoom in and out. Worthing Pier. And we are directly in front of Worthing Yacht Club, and we are next to the big main sewer pipe there, main groin. There we go. and I am on the tripod, 2 legs high. There we go. Thank you very much.
Viewing key sites along the coast. The next part of this presentation takes stills from the video and compares them to Google Earth Pro and photographs to identify the various locations along the coast. Section 1 Video. Rodian School, Brighton. Section 1 Google Earth, Rodian School, Brighton. Section 2 Video. St. Dunstan's Hospital for the Blind. Section 2 Google Earth, St. Dunstan's Hospital for the Blind. Section 3 Video. White Cliffs Cafe, Saltdean. Section 3 Google Earth, White Cliffs Cafe, Saltdean. Section 4 Video. East Saltdean, opposite Telscombe Tie. Section 4 Google Earth, East Saltdean, opposite Telscombe Tie. Section 5 Video. Rushy Hill Cliffs, Peacehaven. Rushy Hill Caravan Park. Rushy Hills Cliffs, Peacehaven. Section 5 Google Earth. Error in Google Earth. Rushy Hill Cliffs, Peacehaven. Section 5 Google Earth. Error in Google Earth, this should be Cliffs. Rushy Hill Cliffs, Peacehaven. Rushy Hill Cliffs, Peacehaven, and Seaford Head. Section 6 Video. Seaford Head. Section 6 Google Earth. Real footage. An error in Google Earth. Seaford Head. Again, Seaford Head. And Seaford Head from another angle. Section 7 Video. Beachy Head. Section 7 Video. Beachy Head. Section 7 Google Earth. Beachy Head. The Seven Sisters in Beachy Head. Line of sight from Worthing Yacht Club of the Seven Sisters in Beachy Head. Section 7 Video. Beachy Head. Still taken from the video. Brightness, color, saturation, and temperature enhanced. And Section 7 Video. Still taken from the video. Brightness, color, saturation, and temperature enhanced. What was the furthest point that can be observed along the coast? The White Cliffs on the west side of Beachy Head are the furthest piece of land that can be observed in the video. These are stills taken from the video. The angle of the sun and observer relative to the cliff was such that a significant amount of reflected sunlight off the white chalk cliff was recorded by the camera, a case of being at the right place at the right time. Still taken from the video, brightness and color enhanced. Is Beachy Head the furthest land that can be observed in that direction? There is no other land or cliffs past Beachy Head. What was observed was the west cliffs of Beachy Head. Numerous drone footage videos of these coastal regions are available on YouTube. How far is Beachy Head from Worthing Yacht Club? The white cliffs on the west side of Beachy Head are the furthest piece of land that can be observed in the video. Still taken from the video. Viewing distance, 44.2 kilometers, 27.4 miles. Still taken from the video, brightness and color enhanced. How high are the Beachy Head West Cliffs? "79 meters in height along the Seven Sisters. "79 meters above mean sea level, haven brow of the Seven Sisters. "79 meters above mean sea level, the Seven Sister Cliffs. And here's another website, Seven Sisters, 79 meters above mean sea level. Beachy Head, Seaford Head. The cliffs reach a maximum height of 156 meters at Beachy Head. Google Earth Pro heights approximately match the government document heights, 157 meters. How high are the west cliffs at Beachy Head? Above mean sea level, elevation 45 meters. To be prudent, a height of 45 meters for the west cliffs on Beachy Head will be used, knowing that there could be a plus or minus 2 meter difference. Tide data for Sunday the 5th of May 2019. The tide level at 1620, 2 meters above LAT, or lowest astronomical tide. Tide level at Beachy Head is between New Haven and Eastbourne, so a mid-value will be taken. Tide level at 1620, 2.67 meters above the lowest astronomical tide. What is LAT? Below is a diagram showing the different tide levels. Lowest astronomical tide is defined as the lowest tide level which can be predicted to occur under average meteorological conditions and under any combination of astronomical conditions. Many national charting agencies, including the United Kingdom Hydrographic Office and the Australian Hydrographic Service, use the LAT to define chart datums. Data analysis. Worthing tide level above LAT, 2 meters. Worthing mean sea level, 3.3 meters. So Worthing tide level, 1.3 meters below MSL. The camera on beach at Worthing, 1 meter above MSL. Camera on tripod, 1 meter above the ground. So the camera height is 3.3 meters above tide level. Beachy Head tide level above LAT, 2.67 meters. The Beachy Head mean sea level, 3.7 meters, so 1.03 below MSL. The cliff is 45 meters above MSL, so the cliff height is 46.03 meters above tide level. Summary. Beachy Head was observed from Worthing Sailing Club at a distance of 44.2 kilometers or 27.4 miles. The camera at Worthing was 3.5 meters above tide level. The West Cliff at Beachy Head was 46 meters above tide level. What does the Earth Curve Calculator say? Metabunk.org calculator. Geometric hidden 110.49 meters. Refracted hidden 92.03 meters. According to the globe or similar sized oblate spheroid ellipsoid model, at a distance of 44.2 kilometers or 27.4 miles, the hidden geometric height is 110 meters. Although standard refraction is a pseudoscience reification, we shall use it just as a comparison. At a distance of 44.2 kilometers, 27.4 miles, the hidden refracted height is 92 meters. What does hidden geometric height and hidden refracted height actually mean? Hidden geometric height. Using mathematical geometry, it can be calculated at what distance one point on a circle or sphere, point A, cannot be seen from another point, point B, due to the curvature blocking the line of sight. The height from the surface of the circle sphere that would not be visible at a distance between the 2 points due to the curvature blocking the line of sight can also be calculated. This blocked height from tide level upwards due to curvature is termed as the hidden geometric height. In the example below, the observer at point B cannot view the white cliff at point A because the curvature of the circle sphere the observer is on is blocking the line of sight to the cliff. The greater the distance the observer is from point A, the more around the curvature the observer will be relative to point A, and the greater the hidden geometric height will be at point A. Hidden refracted height. Survey done over land across large distances attempt to take into account the assumed refraction of light over land. The surveys assume that the Earth is curved and the land they are surveying is curved. The surveys assume that as light travels, it bends around the assumed curvature. An adjustment is applied to the readings based on the assumed refraction of light occurring at 7/6 of the assumed radius of Earth. Assumed means that these assumptions have not been proven scientifically by the application of the scientific method. The consequences of these assumptions is that the hidden refracted height is less compared to the hidden geometric height, which means using the hidden refracted height, less of the location from the ground up at point A will be visible compared to if the hidden geometric height value was used. This is illustrated in the diagram below. If this observation was carried out on a globe with a radius of 6,371 kilometers or 3,959 miles, or a similar sized oblate spheroid ellipsoid, at a distance of 44.2 kilometers, 27.4 miles, then the curvature blocking the line of sight would result in the following hidden heights at point A. Hidden geometric height, 110 meters. Hidden refracted height, 92 meters. If the observation was carried out on a globe, then no section of Beachy Head West Cliffs lower than 92 meters above the tide level would have been visible. If the observation was carried out on a globe, then no section of Beachy Head West Cliffs lower than 92 meters above the tide level will have been visible. The 46 meter above tide level cliff was observed. If we lived on a globe, that white cliff would not be visible. If we lived on a globe, would the Seven Sister Cliffs be visible? The midpoint of the Seven Sister Cliffs is 42.4 kilometers, 26.3 miles from Worthing Yacht Club. According According to the globe, or similar-sized oblate spheroid ellipsoid model, at a distance of 42.4 kilometers or 26.3 miles, the hidden geometric height is 100 meters. Although standard refraction is a pseudoscience reification, we shall use it just as a comparison. At a distance of 42.4 kilometers, 26.3 miles, the hidden refracted height is 83 meters. Beachy Head tide level above LAT 2.67 meters, Beachy Head mean sea level 3.7 meters. So Beachy Head tide level is 1.03 below mean sea level. Cliff 79 meters above MSL. So the cliff height plus mean sea level is 80.03 meters. So the cliff height 80 meters above tide level. If the observation was carried out on a globe, then none of the seven sister cliffs would have been visible at a height lower than 83 meters above the tide level. But the seven sister cliffs were observed. Conclusions. It would not be possible to observe the west cliffs of Beachy Head if we live on a globe, or similar-sized oblate spheroid ellipsoid, with a radius of approximately 6,371 kilometers or 3,959 miles. They were observed and recorded. We do not live here. Can we be sure? Can I prove to you that what was observed, the cliffs, were not behind the curve? Yes. The fact that an inferior mirage is present due to the refraction of light in an upward direction proves that the object observed, the cliffs, are where they are observed and not behind the curve. What is an inferior mirage, and how does it prove the cliffs were not behind the curve? The hot tarmac road, inferior mirage, is the situation most people have witnessed. On a hot sunny day, that tarmac or concrete road absorbs the sunlight, considerably raising its temperature. The hot road heats the layer of air directly over it. This results in an air density gradient that consists of a layer of hotter, less dense air above the road, underneath a layer of cooler, more dense air above it. The light reflecting off the car and passing through the density gradient is refracted in an upward direction, resulting in an inferior mirage, being observed as illustrated below. Sunlight reflects off the car. Light refracts in an upward direction. Human brain assumes light travels in a straight line and sees the refracted image at the end of the green dashed line, called an inferior mirage. An air density gradient is present. Cooler, more dense air is above warmer, less dense air. The light changes direction in an upward direction relative to its prior direction of travel. This type of refraction produces an inferior mirage. The refracted image is always observed inverted and below the actual object. Simple way to remember: image below object equals upward refraction of light. This is a proved and known scientific principle. The inferior mirage over water. Another example of the upward refraction of light. A portion of light from the sun is reflecting off of the buildings and land and traveling out to sea towards the observer. Light rays initially traveling downwards towards the sea will pass through the density gradient and be refracted in an upward direction. This results in the viewer out on the sea looking back at the land observes an inverted image known as an inferior mirage. The refraction of light in an upward direction. Note, below the yellow line is actually sea, but it cannot be observed because we are observing the inferior mirage of the boat in front of it. The same as on a hot day, it looks like a pool of water is in front of a person standing on the black tarmac. Were inferior mirages occurring along the coast? Inferior mirages can be observed all along points of the coast in the video footage. Inverted images can be observed underneath the actual objects, the cliffs, which occur due to the refraction of light in an upward direction. The red line is termed the mirror line. The actual object is above the mirror line, and the inferior mirage inverted image is observed below it. Summary. An inferior mirage is always observed inverted and below the actual object. An inferior mirage is observed because light reflected from the object refracts in an upward direction as it passes through a density gradient. And what does this prove? If the object was behind the curve, it would not be possible to observe the inverted image, the inferior mirage. Proof of an inferior mirage and light refracting in an upward direction is an observed inverted image under the actual object, which is easily detected by drawing an appropriate mirror line through the picture. The green line represents a ray of reflected light traveling in a straight line. The pink line represents the path of a ray of light being refracted in an upward direction, which is necessary if an inferior mirage is to be observed. If the actual object is behind the curve, can the ray of light refracting in an upward direction be observed by the camera at point B? No, it will obviously travel over the camera. If the light refracting in an upward direction travels over the camera, will an inferior mirage be observed by the camera? No, obviously not. On a globe, it is not possible for an inferior mirage, an inverted image underneath the actual object, to be observed because the ray of light refracting in an upward direction will not enter the observer's eye or device. However, it is possible for an inferior mirage to be observed as an inverted image underneath the actual object at a distance of 44.2 kilometers or 27.4 miles over a flat surface. Would light being assumed to bend around the curve produce an inferior mirage? No, it will not. If this was occurring, then only a normal image will be observed as illustrated in the diagram below. Is it at all possible for an inferior mirage to be seen on a globe? Note, for an inferior mirage to be seen, the ray of light must be refracting in an upward direction as it enters the observer's eye or device. For the light to reach point B from point A, the following stages would have to occur. 1. The sunlight reflects off the cliffs and travels around the globe. 2. The light then starts to refract in a downward direction due to the sudden presence of a vertical density gradient. This does not ever happen under normal everyday conditions in the UK. The light then starts to refract in an upward direction due to an immediate inversion in the vertical density gradient. This does not ever happen under normal everyday conditions in the UK. 4. But this would only result in inferior mirage, inverted refracted image, being seen by the observer and not the actual object, and this does not happen. Are there any photos that show this? No. Applying the known scientific principles of light, refraction, and density gradients at sea, it is not possible for an inferior mirage, a downward inverted image, to be observed underneath the actual object under normal, non-specialized, non-manipulated atmospheric conditions on a globe. If anyone says it is possible for an inferior mirage, downward inverted image, to be observed underneath the actual object on a globe under normal, non-specialized, non-manipulated atmospheric conditions, draw a diagram for them as illustrated below and ask them to sketch on it how it will work, following the known scientific principles. 1. The observer must see the actual object and a downward inverted image, inferior mirage, underneath it. 2. The rays of light that result in the observer seeing the inferior mirage must be refracting in an upward direction as they enter the eye or device. And 3. The density gradient must be vertically identical across the surface of the water from points A to B. When a person cannot do this, they will engage in one or more of the following: obfuscation, deflection, word salad, direct you to a model. If they attempt any of the 4 points above, ask them for their own personally empirical evidence to support what they are saying. When you don't receive it, which you won't, you will immediately know the person is disingenuous and lying. No known scientific principles can be applied to this observation that disproves that we do not live on a globe, or similar-sized oblate spheroid ellipsoid, with a radius of approximately 6,371 kilometers, or 3,959 miles. It is incontrovertible, unless you are a science denier. My sincere thanks to Lee the Ham for the use of his P900. I did not deserve to have such an amazing piece of kit that I take for granted. Paul the Plane for his technical support in the production of this video. All the people that I am sharing this most wonderful and interesting journey with, for their support, questions, discussion, and most importantly, their friendship. And then I pointed the camera to the west of Worthing Sailing Club and observed this piece of land. But let's leave that for the next video.